All right, hi everyone. Today we're going to talk about the geologic timescale and mass extinction. So basically the whole history of the Earth. So I'm going to move through this stuff pretty quickly, but you can obviously pause or fast forward or rewind as needed. Okay, so when we break down the history of your life, you use big events, right? And that's how you can kind of segment your life by figuring out when these major things happen. Geologically, we're going to do the same thing. We're going to use relative age dating and absolute age dating, right? To use all of those different things we've talked about in order to try to take the vast history of Earth and break it into segments that we can then use to have a better understanding of how our Earth has evolved over time. Okay. Now we do that on the geologic time scale through eons, eras, periods, epochs. Those are the terms that we use. Eons being like the big chunks, going all the way down to the epochs, which are the small chunks of time. So we're going to kind of go through this, and I'm going to use a calendar here to represent or show you a relative idea of how the Earth has changed. So the Earth formed, we'll say, on the 12 a.m. on January 1st, right? And then we'll say that today or currently it's December 31st at midnight, right? So the end of the year. So we're going to kind of put the major events of Earth's history within this time frame, okay? So we're going to start off with, and I'm going to show you the actual geologic time scale. So down here in the bottom right-hand corner, the Hadean, that is where we're going to start off with everything. And that is 4.6 billion years ago, okay? And that was Earth's formation, right? So you can think of like Hadean as hell on Earth. We didn't have a solid surface really at this point. A lot of outgassing was occurring, so we were getting our primitive atmosphere. And then what happened then was, and you can see here, we're at February 9th at 3 in the morning. So basically all of January into February, that is when rocks were formed. Okay, so how we can kind of figure this out or mathematically looking at this is if we know that Earth formed 4.6 billion years ago and we have rocks show up at 4.1 billion years ago, that represents 11% of Earth's history. Okay, so the Hadean era was 11% of Earth's time. So 11% of Earth's time basically was just the formation of rocks. Okay, so you can see this animation here is trying to show you that where we were starting to get maybe some water collecting on Earth's surface, but we did have some areas that were still very hot and not hospitable, but we were starting to get what you would start to recognize as a normal planet. Okay? All right, so now we're going to fast forward to March 27th at 2:24 in the afternoon. Okay? Now March 24th is the Archean, and this is when life shows up. Okay? So it took all the way into March before we had very primitive basic life forming up. And this is the earliest fossil record that we have on Earth. So prior to this, we have no evidence of life, but at this point we see algae, bacteria, very simple life forms. But again, it took about a quarter, again, mid-March, took about a quarter of Earth's time for life to develop, okay? All right, now look at this. This is interesting. We're fast-forwarding all the way to June. So we went right through April all the way to May. Now we're at June 13th at 6 in the morning. What do you think happened here at this time? It's what we call the Proterozoic. At this point is where we started to get early life. So a little bit more complex, multicellular organisms during this time. So we had these things called stromatolites start to develop, and this is really when we started to get oxygen developing in the atmosphere. Okay, so these are stromatolites up in the right-hand corner. So we're in June, right? And at this point, we're just now getting complex life forms, okay? And not even complex by today's standards, just bigger and more complex than bacteria. So here's an important concept or idea, and that is that life evolved before there was oxygen in our atmosphere. So that early life created the oxygen in our atmosphere. So that early life forms were using the sun for energy, right? Chemical processes also, but they were producing oxygen, and eventually that oxygen started to accumulate up in our atmosphere. Okay, so now that brings us, now look at this. Now we're way down here in November. Okay, so we went from June all the way down to November 13th. So we're getting close to the end of the year. And this is what we call the Cambrian period. okay, is the start of this right here. So this would be the start of the Paleozoic and the Cambrian period. And the Cambrian is when we have what we call the Cambrian explosion. And this is where we really see life start to get interesting. Okay, we start to get shelled animals, so we're more complex now. These things are called trilobites, right? Brachiopods, you can think of kind of as like clams, oyster type creatures. And this was 87% of Earth's history before this occurred. So it took a long time to get to the point where we have some interesting things swimming in our seas. Okay, about 500 million years ago, we start to get the first vertebrates. Okay, so these are our primitive fish that we see in the sea. So things that have a spinal column, guys like this right here. So here's a trilobite down here in the corner. But so again, 89% of Earth's history before we start to get vertebrates. Now again, keep in mind, nothing is on land at this point. There's no life on land yet. This is all just in the ocean still. Okay. All right, now we get to November 24th, so we're getting close to our Thanksgiving, if you will, at 1:12 in the evening. This is the Ordovician. And this is where we had the first mass extinction on planet Earth. Okay, so again, 444 million years ago, 90% of Earth's history, and we get our first mass extinction. Okay, so now mass extinctions, we'll talk about this, but they're not like always sudden events. Sometimes they can take millions of years to occur, but you see a mass die-off. In this case, 85% of species went extinct. Okay, so that's what we are calling a mass extinction. We believe at this first one it was major glaciation, so it was a global cooling period on Earth, which led to this mass extinction. Okay, all right, now let's go ahead and fast forward to November 28th. All right, so in Earth's history, and this is the Silurian, and in the Silurian is when we first get plants on the surface of the Earth. So prior to this, there wasn't really life on the surface of the Earth. Okay, so we now start to get the oceans are pretty dynamic. Right? We've got some interesting critters swimming around in the oceans, but land is pretty dull at this point. And the plants are not like plants that you think of today. They were a much simpler form of those. So that was 91% of Earth's time before we got plants. Now, when this occurred, right, and a lot of this is we're starting to get oxygen really starting to accumulate in the atmosphere. This kind of provided an opportunity, right, for insects and other things to move onto land from the water, because it was kind of this open niche, right, that these organisms could maybe try to take advantage of. Okay, so the oceans were very dynamic at this point, and the land starts to get a little bit more dynamic. Okay, all right, so that brings us now to December 1st. Okay, December 1st at 7:12 p.m. This is the Devonian. Devonian now is where we start to get animals, if you will, up on the surface of the Earth. And the first ones to do that were amphibians, right? So that they were, and they believe this happened kind of in swampy environments where there were insects and whatnot up on the in these environments. So the amphibians evolved to kind of fill this niche, right? That there was an opportunity. So they started to use their fins and flippers to navigate over roots and whatnot, and then that led to animals that were successful were ones that were able to partially live out of the water. Okay, so that's how we had the evolution of amphibians. Okay, now at the end of the Devonian, we had a second mass extinction. This one wasn't quite as big. 70% of the species went extinct, and again, we believe this was related to climatic changes on the surface. Okay. All right, now that brings us to December 10th. Now, December 10th was the Permian, okay? And this is right around this time is when we were in Pangaea, okay? And the end of the Permian was the largest mass extinction we've had on Earth at this point. This is not the dinosaurs going extinct. This was earlier, 252 million years ago, which was almost 95% of Earth's time. This was 90% of all species on Earth went extinct. Think about that. 90% of species on Earth went extinct during this time. Meaning, how do we know that? They disappeared from the fossil record. Okay, so all of these critters, we find fossils, and then you get to this point, 252 million years ago, and all of a sudden they all just disappear from the fossil record, meaning that they went extinct. And we believe it's primarily because of Pangaea. Right, so Pangaea had disrupted how the ocean circulated. So it had a major global climate effect, which resulted in this extinction. Okay. All right. Now we're at December 11th. Early in the morning here. This is the Triassic period. Okay. So this is going to be in the Mesozoic. Okay. So Mesozoic is famous for lots of children all over the world because this is where we have dinosaurs show up. Okay. The first dinosaurs show up, and again, 95%, 94.6% of Earth's time, dinosaurs show up very late in Earth's history. That's the Triassic period. Also, we see mammals, okay, show up. Little small mammals, okay, but mammals did show up. At the end of Triassic, we had a fourth mass extinction. So you can see we've had multiple mass extinctions in Earth's history. 20% of marine families or species went extinct, as well as most mammals. Okay, at that point, we didn't have very many mammals on Earth, but most of them went extinct, and many of the large amphibians. Okay, again, they think there could have been an asteroid impact at this time, but again, that's an area of active research. All right, now we're getting close to the end of the year here. December 21st. Okay, December 21st. That's the Cretaceous. You can see Earth is starting to look, right? Pangea has split up. It's starting to look kind of how we are now. So you can see this is just kind of showing an animation of history of Pangea coming together. Right there, there's Pangea coming together in the Triassic, and then Jurassic, it starts to split up. Okay, that brings us to where we are with the Cretaceous. So Cretaceous, during this time, this is where we start to get the first flowering plants and hardwood. So you can think in the terms of like the plants that are on Earth's surface now. Right around this time is when it started to look like it does now. Okay, so we had seeds, right? Plant or flower-bearing, fruit-bearing, seed-bearing plants producing some of our typical trees that we see nowadays. All right, so then this is an actual image of a boundary of kind of a layer of soil. And if you look at layer A down at the bottom there, that was before the Cretaceous. Okay, so that was before the impact. And you can see you've got the mudstone to coal. You can see the light brown here going up to the darker colors. And they think that's because the climate was shifting from dry to wet, which was perhaps putting some stress on the dinosaurs anyway. And then you can see layer B here, right? We have no dinosaur fossils. You can see that little layer right there. We have no dinosaur fossils above that layer, and this layer is found all over the Earth's surface. Okay, and we find this iridium and elements that are rare on Earth but plentiful in meteorites. So this is really signifying when that asteroid impact that ultimately led to the dinosaurs going extinct. Okay, so basically, forests collapsed. We had lots of microfossils in coal. So kind of evidence showing how the planet had changed after this impact. Okay, so this would be the fifth mass extinction event. This is the famous one that everyone knows about, and that's the extinction of the dinosaurs 65 million years ago. But again, that happened just a blink ago in Earth's history. Okay, 98.59% of Earth's time had passed when this occurred. Okay, all right. So now, important idea here is that think about this. Although there are 10 to 14 million different species currently on Earth, okay, 99% of all species that have ever lived on the planet have gone extinct. Okay, so extinction is a very normal process on Earth, and we see since the 70s we're actually having a population decline right now within species and vertebrate animals. And part of that is, again, because of habitat degradation and exploitation and pollution and all these things. And you can see here there is a normal background extinction rate. But the vertebrates and birds and mammals, and we're seeing a much higher rate of extinction occurring now. And we believe it's related directly to the number of people on Earth. Look at the population of Earth, how it's changed over the past 2,000 years. Okay, we're approaching 8 billion people on Earth, which is a lot, and that's obviously going to put a stress on the resources, and especially as humans spread throughout. So this human population and extinctions kind of go hand in hand, which leads scientists now to believe that we are in the middle of our sixth mass extinction event. And again, humans are the primary driving factor behind that. Okay, so this is just a summary kind of showing all of those extinctions that have occurred. There's the dinosaurs, and then we're, again, experts or scientists believe that we're in the middle of our sixth one now. So again, it can be a slow event, but all right, let's fast forward here. Look, December 26th. okay, 9:21 p.m. So now the dinosaurs are gone. This is the Paleogene. The Paleogene is where we start to see abundant placental mammals. So mammals that are giving live birth with placentas, and we get this diversification of mammals. And again, primarily because the dinosaurs are gone now, right? So that provided this little opportunity for us. Grazing mammals really diversified about 35 million years ago. So again, the mammal population is really beginning to diversify. Now, here we are, last day of the year, December 31st at 3:15 or 3:14. This is the Neogene. This is when finally hominids show up, okay, Australopithecus. So not Homo sapiens, not us, but these are upright walking apes, okay? So not something that was significantly different from what has appeared in the past, but are a relative of us, right? We are hominids as well, but Australopithecus is now extinct, but this was the first upright walking ape, which we call hominids. And so they showed up just very, very recently. And what this means is humans, right, we only represent a tiny, tiny percent, a tenth of a percent of geologic time. Okay, so we are babies on planet Earth. We have not been here very long. All right, so last day of the year at 9:22 p.m. This is when we have the Pleistocene, right? The Ice Age, as we've talked about, 1.6 million years ago. That was the Pleistocene. And here we are now, look, December 31st, 11:59. So the last minute on the last day of the geologic year, and that's the Holocene. And that's where we are now. Okay, so it started at the end of the Ice Age, about 12,000 years ago. And 99.9998% of Earth's time has passed. So think about that. That little tiny, whatever that is, 0.2 millionth of a percent or whatever that is, that's all of what we would term as history, right? Is in that short amount of time. So tiny fraction of time is when we have been on planet Earth, okay? All right, so big picture here. We got life, we got oxygen, we got the mass extinctions, and then the dinosaurs were living during the Mesozoic, where we are during the Cenozoic. Okay, again, as I said, a little bit of a longer notes, but again, we covered the entire history of the Earth in under 18 minutes, so I guess I feel pretty good about that. If you guys have any questions, obviously reach out to me in class or by email. See y'all.